Welcome back to the Aprilia Performance technical bits. So there should be a little bit flashing up on the screen. No, there isn't, sorry. It's not that complicated, but actually that might be an idea. I don't know. Well, let us know. Let us know on this side. Right, Gen 2 charging systems, issues. The lads and I are seeing an awful lot of people asking questions about how this is happening, what's going on, an explanation of how this is occurring, what's going on and why, etc. So what I'm going to do is we've decided to put a little bit of a film together to try and explain to people exactly what's going on, what this brown block connector modification is that are people doing, how to check the system to see if you've got this particular problem, how it's fixable, what we've found so far. Believe me, we've spent hours and hours and hours, and we've had time in court about this. We've just spent thousands and thousands of pounds trying to fix this problem a cheap way or an easy way, and there isn't one yet that I've found. We've got guys out there that do many miles. Rob, how you doing, my friend? Rob, he does thousands of miles a week because he uses his bike to commute on. We've used him to test many times, so he's a good man and we've tested him, so we kind of owe him a beer, to be honest with you, as it sits. But what I'm going to do is explain how the system works, what this brown block connector modification is, how to test the system to see whether you've got this particular problem, and then we'll sort of show you how to fix it at the end. So we've got a conclusion on how to fix it, or how we found to fix it in the end. So basically, a brief explanation about a charging system. A charging system is a method of being able to charge your battery sufficiently to be able to run the 12-volt components that run on your bike. That would be an ECU, a bulb, anything that takes 12 volts has to be run by the battery. So something's got to recharge that battery. Now then, how do you generate electricity? You only generate electricity in AC. So basically, without going into too much detail, because we're not at school anymore, but basically, did you pay any attention at school? No, neither did I, so it doesn't really matter. But we can generate voltage that's enough to charge a battery in AC only. So what we have is we have a set of coils, some wire. We also have a flywheel. So we have the soft iron core, the copper windings, and we have a rotating magnet. This generates voltage in AC. So we can only generate voltage in AC. This has to get turned into DC to actually charge the battery. So this is done by the Regulator Rectifier. I'm sure you've all seen a Regulator Rectifier. I'll have one here in a little bit just to show you what's going on, because I've forgotten to put one down, but not a problem. So the Regulator Rectifier. The regulator stops the system from overcharging, so it regulates the charging voltage. The rectifier turns AC into DC. Simple as that. No need to go any more complicated. If you can get your head around that, you'll be absolutely fine. So we've got the flywheel, we've got the windings and the soft iron core. You can only generate electricity in AC, so we have to turn AC into DC. Okay, we have to stop the system overcharging. Obviously, the faster you rev the engine, the more you rev the engine, the more the voltage you'll generate. The situation is, and this is what's going on that we've found so far, the flywheel and windings that come with a Gen 2 that have they all have this brown 3-wire block connector on them. All of the bikes have these 3-wire block connectors on. Now then, the symptoms that we're getting is that these block connectors are burning up, and we're burning out these stators. The situation is, as we see it, the 500 watts, this generator that will come standard, comes rated at 500 watts. The 500 watts is too much. So what happens is, the excess energy cannot be distributed. Clearly, you can only turn energy into something else. You can't destroy it. So what happens is, the electricity that's generated charges the battery. When the regulator realises that there's no need for it anymore, what it does is it switches over this excess energy by the use of a transistor in the Regulator Rectifier to the heatsink. You've seen the heatsink on a Regulator Rectifier because it has fins. These fins basically the air rushes over these fins, and it dissipates the energy. The problem that we've got is that the 500 watt generator that we've got is too powerful. It generates so much electricity that the heatsinks can't get rid of it. Now then, I've got a brief explanation about regulator rectifiers. There's 3 types of regulator rectifiers. We've tested all 3 types, and we've found difficulties or issues with all 3 as it sits. This is going to get controversial, but I don't care, because I have actually tested this in my workshop and I know what's going on. The problem that we've got is that There's three types of regulator rectifiers. There's what's called a shunt type, which is the standard regulator rectifier we see on our bike. There's called a MOSFET type, which we don't see on our bike, but some people are fitting them as some kind of a way of being able to try and get around this problem. It doesn't work. I've tested this. And we have what's called a series type regulator. Now these could work if coupled with another part. So bear with me, this will all become sensible. So the shunt type switches over onto the heat sink exactly the same as it would do on a standard bike. The MOSFET type does exactly the same thing, where it doesn't destroy the energy, it just turns all the excess energy over onto the heatsink. We get rid of the energy that way. The series type opens the windings and sends these windings open loop. Now these could work coupled with a good, reliable set of windings. And there's another point that I've got to make. Unfortunately, in our testing, we found that rewound stators don't work. They last very, very short space of time, so they don't work. Give me a few seconds, I'll go and grab a regulator rectifier and show you what I mean. Talking about brown block connectors, this is the regulator rectifier, this is where it's come from. This is the part that, like I said, this is where the air rushes over the fins on the regulator rectifier and dissipates the excess energy. The regulator rectifier is the part that regulates and rectifies, so you can't destroy energy. All you've got to do is to be able to turn this into something else. So we turn the excess energy into heat. Air rushes over, we get rid of it. Now then, we're going to talk about brown block connector deletes. The brown block connector delete is this block connector. If you see what you've got, this goes together from your stator. This runs through the engine over to the other side on your bike. This then goes like, turn it the right way around, like that together. The brown block connector delete is where people are actually cutting this brown block connector out and soldering these wires together. This has got to be done correctly, otherwise you can create problems artificially. Now the problem we've got is, and this is the bit of information that I wanted to try and give you, was that this symptom, and it's not a problem, it's a symptom. This symptom that you see when you're trying to pull this apart and it's starting to melt, and this brown block connector delete isn't actually the problem, it's a symptom of the problem. So all you're going to be doing is fixing the symptom of the problem. The excess energy is built up, this starts to turn into heat as this is an area of resistance and it starts to melt it. Okay, so basically if you're going to chop it out, do it properly, but be careful and understand that there's probably something going wrong inside, or understand exactly what's happening so we know what's going on. All I've got to do now is I will actually put this all together and I'll show you how to test it all, so give me a moment. Okay. So this is how your bike's going to be laid out, or this is how the system is laid out on this particular bike. What I'd like you to do is sort of, if you can imagine it, use your imagination. We have to quite a bit sometimes, don't we? But basically this is the part that's bolted to the end of your crank. Okay, this wire runs through the centre of the V over to the other side of your bike. Then you'll find the sort of regulator rectifier is bolted to the side of the fairings. Not a problem. This is your brown block connector. So what we're going to do now is how to test this system to find out what's going on. First things first, I'd like you to go to your battery. I need you to grab a multimeter. The voltmeter that's on your dashboard is not reliable. If you get this a separate multimeter, yeah, mine's quite a good one. But what we're looking for is just to check to see whether your bike is charging or not. So, two terminals. I'd like you to check and make sure that your terminals are on and your meter is on DC volts. That's DC volts because we're checking post regulator, post rectifier. Okay, DC volts on the 20 volt scale. If you put your two terminals, red on the positive, black on the negative, onto your battery, start the bike and check to see if it's charging. Your charging rate should be somewhere between 13 volts and 14.5 volts. If it's between there, your bike is charging. Check it whilst it's cold, check it whilst it's hot, and check it at tick over and check it at 3000 RPM. If it runs in between those two parameters, I'd suggest your bike's okay. Not a problem. Okay, if it's not, then I'm going to show you what to do to check the AC output, because it's AC output that we're looking for, at this brown block connector. You can only test the stator with the stator isolated. So if somebody's done the brown block connector modification or deleted it at some point, it needs to be separated so we can test what's going on. So we need to be able to get hold of and keep that like that. So we need to be able to get to it like this, not a problem. Then I'll show you how to test this, okay? We have got the meter. We need the meter back to be able to read AC volts. So we change the meter onto AC volts, and we need it to go on the 200 volt scale. Okay, so that's 200 AC volts. If we can check this, and we've got this on your meter before you start, you know you're onto a winner. Okay, so we check this, and then what we're looking for is this. You can rewind this, it's not a problem, it's going on the YouTube channel, so you can rewind this and check this out, see if you need to check on what's going on again. But this is how you check it. If you can imagine numbering these terminals here, 1, 2 and 3, you need to check between 1 and 2, 2 and 3, and 1 and 3. Okay, that's how you check it. I want you to get the engine running warm, and I'd like you to check the AC volts output at 1 and 2, 2 and 3, and 1 and 3. If you check that at tick over, it should be, I'd suggest, around 15 volts AC, and at 3000 RPM it should be at around 45, 50. Something like, maybe even, yeah, go 30, go 45, go 40 to 50 volts AC. So we're checking between 1 and 2, 2 and 3, 1 and 3, like that. Okay, tick over, I want to see about 15 volts AC, and at 3000 RPM I'd like to see about 40 volts AC, between 40 and 50 volts AC. If you've got lower than that, you have got a problem. You've got a situation that we're looking at like this. If you can see the difference between the coil windings, this stator here has been subjected to massive amounts of heat. This came out of a bike this morning that we did that was giving much lower voltage readings than those ones. That's what it should look like. And we've got boxes of these. We've got boxes of these that are rewound ones that didn't last a few hundred miles. Like I said, it doesn't work. I don't care. I've tried many different people. It doesn't work. That's what it should look like. Okay? We've had different kind of stators come from all over the world to check. We found that unless you've got a series regulator, which in theory should work, but we've not managed to check yet, to be honest with you, 100%. But the only fix that we have found that is reliable so far is one of these. This is an updated flywheel and stator assembly from Aprilia that was designed to go on the 09 to 00 onwards, that retrofits onto the 04 RSVs, not a problem. This is the only reliable way we've got of being able to assure you that your charging system is fixed. This is as unfortunately, this is all we can recommend so far. It's not a cheap fix, unfortunately, but it's the only one that's reliable at this particular point in time. So just to recap, explanation of the system. We've got a 3-phase system, okay? 3 phases, there's 3 wires, 1, 2 and 3. Okay, this goes then, the energy then goes to a regulator rectifier. The regulator controls the amount of energy that's coming from the stator into the battery. Obviously, if it's too much, it can bore your battery dry. Okay, then the rectifier turns AC into DC, which means you can run bulbs, not a problem. Okay, brown block connector modification, like I said, it's a symptom, not a fix. This is what's going on. The excess energy from that stator cannot be got rid of by conventional methods that actually Aprilia have decided was a good idea. Can't be done. So what they're trying to do now is basically rate down the stator slightly less. I believe that the windings were about 360 watts instead of 500 watts energy. I think that's the figures that are springing to mind at this point in time. I've got a camera pointing at me, it's pretty scary. Okay, AC into DC, okay, you know how to test. DC, test your battery, make sure it's charging. AC, we've got 1 and 2, 2 and 3, 1 and 3. We've got 15 volts at tick over, and I want about 45, okay, at 3000 RPM. Any problems, give us a call. We're happy to help. It's not a problem. You can get in touch with the office. You can call us at service. You can get in touch, so you can email us at service@apriliaperformance.co.uk. You can go onto our website, www.apriliaperformance.co.uk, or you can even check out our YouTube channel, Aprilia Performance UK, if you're not already looking at it. Any questions, get in touch. Thanks very much. See you soon.